What's up, guys? It's Clay from Verus Engineering. Today we've actually got some special testing planned here out at Putnam Park Road Course. We have our good friend Dustin helping us out with some interviews. Dan will be driving the car along with Justin, and in between sessions we're going to be swapping out aero so we can do comparisons between no aero, full aero, and then we'll also be doing some wing testing as well with the car.
So we want to see what our aerodynamic components do to overall vehicle performance with both a typical track day enthusiast as well as a professional driver. Some of the things that we're taking out of the equation that a lot of people don't think about is traffic on track. For all intent and purposes, we're basically the only car on track. Currently, we are the only few people here. Without traffic, we now can basically remove that entire part or issue out of the equation. A lot of people don't realize that traffic during track days actually really does impede lap times. Some things that we're going to be looking at on track are lap times, lateral Gs, brake pressure, throttle position, how long they're on the throttle. We're going to be looking at all that, and we'll go over that later on. But first, let's get back to the shop and check out how we set up the car with laser ride height sensors and sensored up the car. All right, guys, so we're back at the shop. We have worked on Justin's car just a little bit. We basically removed all his aero that he previously had. So he had our rear diffuser, our front splitter with the front splitter end plates on his car. We removed that because our first test is going to be no aero. I've also laid out the deck lid that we're using. Shout out to Sam Sullivan for helping us and giving that to us, I don't know, a year ago. We've really used the heck out of it. Thank you very much. We're going to be testing our very first unit our wing that we ever made, which is the 8-inch or 200 millimeter swan neck wing. And then we're going to run our 250 millimeter curved blade wing that is hopefully coming out within the next few months, and we're just going to be trying to figure out, how it performs on track and what changes they make to the vehicle's performance. So to do that, we're throwing an AIM Evo 5 on the car with both a professional driver and a track day enthusiast, and then we're going to record their feedback each time. The feedback will be opinion based, of course. However, we will take it for what it is, feedback. And we're also throwing like I said, the Evo 5 by AIM on there with laser ride height sensors. So we're actually going to install this all over the car, so 3 units to create a base plane on the bottom of the car. And by creating a plane, we can tell how the car is performing on track. So we'll be able to use that to measure ride height at various locations to see what kind of downforce the vehicle's making. We'll be able to see how much lateral G is changing throughout the different setups. We'll be able to obviously track lap times and various other inputs like throttle position, braking, how much less or more they're braking. All those type of things we'll be able to look at after the track day beyond just regular lap times.
My name is Dan Clarke. I'm a professional race car driver. My experience is anything from IndyCar racing to NASCAR racing and sports cars like Porsches and BMWs. Nowadays, I do a lot of driver coaching, different clients that want to go race different kinds of cars and want to learn how to just get better at it. And I also coach here at Putnam Park's Country Club.
Name's Justin Green. Day job would be a painter. I work in a body shop in Zionsville. Paint cars for a living. My experience is extreme novice. Try to get out as much as I can, but it's not always possible.
This is your personal car, right?
Yes.
What year is it?
It's a 2015 Series Blue BRZ.
Cool. And what modifications are on the car currently, minus all the aero?
All modifications.
Just a basic list.
Coilovers, sway bars. It's got a half cage, seat, Basic bolt-ons, intake, full exhaust, and E85. It's basic stuff.
We did a little shakedown with the BRZ, and that's really important, obviously, to know in current conditions, today's weather, today's track state, just how everything's handling before we start adding on some things. And I've never driven this car before, so it's important for me to get a feel for mechanically, suspension-wise, shock-wise, how it behaves, because when you start adding aerodynamic grip, it's a different element of grip, and the two kind of work together. The two can maybe, or the aero can affect the mechanical. So it's really important to know essentially this mechanical suspension platform of the car, how it behaves before you start adding literal downforce.
So what they're doing currently is Dan had some recommendations for setting up the car a little bit better stock before we go to aero, so we're making those changes, and then he's going to take it back on track, and we might make a few more changes before we throw the aero on.
Well, we have a schedule today for different stages. We're going to add different kinds of downforce, so we're going to adjust the downforce, and so we didn't want to spend too much time working on getting the perfect mechanical setup because we did have a little bit of understeer in the car turning into a corner, and then a little bit of oversteer getting out to the exit. So that's not ideal. So we really just try to make 5 minutes to make a sway bar adjustment in the hopes that we can fix that, or at least make the car more predictable and more consistent from turn in to exit before we start adding the aero on. And then we know that any feedback we're getting from aero, if we can fix it mechanically, is aero alone and not something underneath in the mechanical sense happening as well. So we made a little sway bar adjustment on the front, and I went out and drove it again just in a few minutes, really just conscious that it's not on the schedule, but if we can get it handling better, then it's going to make the rest of the day easier.
Loose. Yeah, the rear would step out and the front started to push a little bit. It was like it was losing front grip.
We went straight to a bunch of the aero stuff. So we had the front splitter, the end plates on the front, the rear diffuser, and the high efficiency rear wing. It was interesting to see what it did to the car, obviously. Going from no downforce to what looks like all downforce at first is going to change quite a bit. From a testing point of view, it was good. We already had a decent platform with just mechanical grip balance and then that to gauge what the aero changes did. And obviously the cornering speeds changed quite a bit. The grip balance front to rear changed a little bit, probably gained a bit more rear grip than front, which if anything is just really interesting to see because it might not be what I would have expected from looking at the car, just standing around it, having a look at what was going on to it aero-wise. but that's why we're here, is to test and see what actually happens in reality. As far as cornering speed, yeah, minimum speeds went up a bit. A lot of the Putnam Park corners are what I would call medium to high speed. So when you start adding aero grip to the car, it really changes the lap time. From a driving point of view, my background is racing things like IndyCar with big wings, big downforce, but it's been a while since I've driven those. So I had a few extra laps just to keep building myself up to what happens when you put aero on a car and you start driving it. A car you're already familiar with, but now has much more high-speed cornering speed potential. You just have to keep talking yourself up to it. Every time you go through a corner on a particular lap, you have to ask yourself, well, did the car move around much? Did the front slide? Did the rear slide? Did it feel like it was near its limit? And if it doesn't, then you just have to keep going, which means every lap you come around to that same corner, visually your approach speed looks like it's the limit of the car, but you know it's got this downforce, and so you just have to keep pushing and pushing until you feel it moving, feel the car moving around again. And so that was fun to do. Definitely gained a lot more speed. Lap time got faster. So now we're going to try another rear wing.
They put their front splitter and end plates on, the rear diffuser and their high efficiency wing. It felt a lot more stable. The back wasn't kicking out as much and the front had a lot more grip. Like I could probably push it harder. Like it was more confidence inspiring.
Yeah, with the going from no downforce to the downforce, turn 4 at Putnam, it's the first left-hand corner. It's over a crest as you turn in, so regular street cars, even with performance tires, but no downforce, really feel that crest because you're going through a right-hand kink on your approach to 4, and you're turning left over a crest. You're sometimes murmuring on the brakes over that crest. So if you think of the pendulum effect of the body of the car, it's going from one absolute extreme all the way over to the other, and you'll feel that, and the car might snap the rear out on turn-in. When you have downforce, that crest almost doesn't exist because the car has just got much more maintained grip all the way through that corner. And so you just have to keep going faster and faster, even though experience tells you most of the times I come through this corner, I lose the rear at this speed. But now you've got downforce, you just have to keep consciously checking you haven't forgotten you've got downforce, so you need to keep going faster. Yeah, I guess in short, it felt as good as the competitor wing. I mean, it's similarly sized, I guess you could say, compared to the high efficiency wing. But in terms of downforce, it felt as good as that. You know, it made the car understeer in the high speed stuff. So since it's a wing and they're going to incorporate it into the other parts of the kit, we started to tune it. And so we reduced it a little bit for the car that it's on right now and with the aero pieces, and moved the grip forward a little bit and then went further again to make it into like a, you know, what you would say a nice balance. And I think it ended up being almost as fast as the smaller wing. And the car is going back out. So the other guy's gonna be driving it now, hopefully enjoying it.
I could actually tell a difference compared to the competitor wing. Speeds were corner speeds were a lot higher. You just tell because the next turns there's a couple times where I Didn't brake soon enough and almost went off, but carrying more speed, it kind of happens. But based on what they're telling me, I was second, 1.6 seconds faster compared to all the other wings.
All right, Dan, you can bring it in whenever. I think we have everything we need.
Awesome, I'll bring it back to the garage. Just on a cool down lap now.
Awesome, thank you.
Honestly, when you start adding a lot of downforce to a car here, this track has so many fast turns that lap time just keeps getting better and better. So your corner entry speed gets so high, you start to find, I guess you could say it's a weakness, but you just start to find the next inadequacy, I guess you could say, in the car. And that sounds unfair to say about a particular car, but the point really is that the cornering speed gets so high with downforce here that you're going to find that the sway bars or the suspension are not dialed in for this kind of lateral G that you're now achieving. You know, the wings just take it to another level, and then you have to go back to the mechanical side of the car, the suspension side of the car, make adjustments for that, because now you're going that much faster. And you know, lateral G means you're producing that much more grip that you're leaning the car over more. And if sway bars and suspension are not dialed in for that, you're not using all of the footprint of the tires. You know, the inside tires are getting lighter, and so you're losing that contact patch. So you have to kind of go back again and adjust that. As far as what feels best for the driver, once you've got the balance you want, front to rear grip, you're always looking for downforce, and that's all you can feel. The other flip side of aerodynamics and downforce is drag, and you can't really feel that, so as a driver. So I would say both of the bigger wings were set to produce more downforce initially, so they both felt good. And that's the benefit of having data here as well, because you can see what speed that all three wing options are really doing down the straightaway. And that's where efficiency comes in. So the fact that the Verus wings prove to be efficient and have a faster speed kind of concludes everything I guess everyone wanted to see. From the driver point of view, I can really only feel the downforce, I guess. So more downforce is always better until I'm not going fast down the straightaway anymore.
This setup, the one that's on it right now, it felt more confidence inspiring, for sure.
Yeah, absolutely. The products are on a Subaru BRZ, and it's got a little bit of track tuning to it. It is on track tires, but it's not on race slicks, and it's still road legal. And so the adjustments Aero makes to the car and the lap time that comes with that, you know, really bumps it up a notch and makes it a lot more enjoyable.
I mean, data doesn't lie, because I was 126 this morning with no Aero, and it's 122.4 or something now. I mean, it's doing something.
All right, guys, we're looking at the data from Dan's runs. Well, I guess first we are using AIM as a data logger. The ride height data is coming from Izzy Laser Ride Heights, and then we write our own math channels, and that's how we have ride heights at the front left, front right, and rear left. You only need 3 laser ride height sensors to do that. So this is
2 runs with Dan Clarke. The blue is no aero, the orange is with our aero, and the high efficiency wing. You can see each of the things we're looking at is brake pressure, front left ride height, front right ride height, rear left ride height, rear right ride height, steering angle, and the vehicle speed. And then also the bottom is a reference, and I'll kind of go over what that means in a little bit. First, we'll look at brake pressure. So one thing you can notice is some of the corners he is braking harder, and that is because he's carrying a little bit more speed. And like this location, you can see that it has a higher spike, but he's braking less. And then this is also higher. And then there's some spots where it's lower, probably because he just doesn't have to brake as much because the aero is allowing that more grip and he can just carry more speed through the corner. So right here, and right here, you can see that. And then right here, he had to brake with no aero, but did not have to brake with aero. And then you can look at in comparison. So if we just go directly down and look at the speed, you can see right here that he's carrying more speed through all of this with the aero. Like there's a lot of places you can actually see that. And then looking at the steering angle, one thing that we definitely noticed is the steering is a lot smoother with aero. You can see how bumpy it is in multiple different places, and with the blue, and it's not like that with the orange. The orange is just a lot smoother, and that is with aero. Now looking at the ride heights, it's a little bit harder to kind of discern what's going on, but just as a broad overview, you can definitely tell the orange lines are averagely lower than the blue lines. Logically, this makes sense because with the aero, you're adding downforce. The spring rates stayed the same, so because the spring rates stayed the same, with more loading, the car is going to be lower around the track. And you can see that. I'll point out a few locations so you can obviously kind of see, but like here, 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 here. Some places it is higher. That's because other stuff's going on, like here, it's a primary example. And then one thing you can do with this data is you can calculate downforce at specific locations from no aero to aero. The best place we found to do that is actually at the end of the straight, which is over here with the actual how the car is located. So since we know all the ride heights, like the front left, front right, rear left, rear right, we can actually set the car up in CFD exactly like that at the specific speed and calculate and correlate the downforce numbers. We're also looking at, you can look at average downforce added throughout the actual lap, which that's in our blog, so you can look at that. Okay, this bottom section is the reference. So the orange line is with aero, obviously, and that because that's our fastest lap, it's going to be just straight across. The blue line is with no aero. And where you see it increasing, this is areas where time is slower on the track for the specific location. So this helps you kind of visualize where the next lap or the parts are really gaining you extra time. At the beginning of the lap, part of it's the straightaway, up to like right here is a straightaway, and you can kind of see they're basically about even going across, which means that we're not adding a whole lot of drag or anything like that. Coming into the first corner, you're not really gaining anything yet either. And then after that, you can really start seeing where we're gaining. So right here is a little bit, and then bam, right here, you can actually see it steps up quite a bit, and we just gain all the way through here. So a big section of the middle of the track, we're gaining a lot in aero, and that's because of the downforce. And it kind of levels off right here. We've seen this on another car also, in similar locations with aero. So aero definitely strategically helps in certain areas of this track and not as much in other areas. So looking at throttle, this is another interesting one. So again, orange is with aero. You can see, especially in the areas where we're gaining, it's a lot more noticeable on the graph. So you can see he is on throttle a lot more of the time than before. So especially like right here is a primary example. So he's on throttle earlier. So he gets on throttle earlier, and you can see that from the peak. And then he stays on throttle longer. And you can see that again on the next corner. You can kind of see it here. It's a little harder to tell. It's not as noticeable. This is also where it's leveling off, which makes sense. And then once it starts increasing again, you can kind of see it. This one's a little harder to tell because you still do have the dip. So he gets off throttle earlier right here, but gets back on throttle. So these look pretty similar size. We could actually see how much of a difference that is. But you can see they end kind of at the same spot. So he's on throttle definitely longer overall. And going into the last corner, he's actually at full throttle. Comparatively, he was never at full throttle before. All right, so one cool thing in AIM that you can do is you can take the average of the ride heights, and then you can also do with some math calculations with known spring rates and everything like that, known motion ratios, you can calculate how much downforce you're actually creating. So that's kind of a cool thing. So compared to aero to no aero, we made an average of about 230 pounds of downforce overall throughout the track on average. We also tested out other wings and other things like that. So we were able to get average downforce around the track. You can also calculate peak downforces in different areas. Again, the data is only so good because you have a lot of data coming in to actually read. It's kind of bumpy. It's not fully smooth. The car's moving for a lot of reasons besides just aero, so it's hard to fully decipher all of the data. However, we did get a peak at the end of the straightaway of around 328 pounds.
So we wanted to basically conclude the testing with like basically what Paul and I kind of discerned or learned from the testing, and kind of like an overview of something that we kind of didn't really think about. And one of the big things for me personally was that a professional driver does not improve his lap times as much as an amateur. And ultimately that's because a professional driver is already using most of the tires, like 98% of like what the tire grip has, without aero. And then with aero, he keeps that same 98%. So then you see that slight bump in lap times, or drop in lap times, where the amateur, because of how the car feels without aero, which is much more scary and loose, he might be using only 70% of the tire. And then as he throws on aero, he can actually bump that up to 80%. And we saw Justin drop his lap time significantly more. And that's something that I took away, which was kind of cool to me. And then let's hear what Paul says.
Yeah, and then I was looking at the data, and one thing that kind of made sense for what we were looking at is looking at Dan's data. It was very consistent. Professional driver, it makes sense. He can do consistent lap after lap after lap. He takes corner 1 the same, he takes corner 2 the same, 3 the same, etc. So every time he takes a corner, it's the same. So it's a lot easier to discern with changing parts on the car. If it goes faster, that's actually because the car is improved instead of the actual driver performance. Like with Justin, his laps weren't nearly as consistent, so it was very hard to discern like downforce data and then what's going on lap to lap, just because he'll take corners a little bit different, and it's just enough that it makes it really hard looking at the squiggly lines in the data of what exactly is going on. Dan was very, very consistent, and it was pretty easy to calculate actual downforce numbers in specific areas using the laser ride heights.
All right, guys, that finishes our test. Hopefully we'll be doing some more of this stuff with possibly the Supra, maybe the Porsche. Porsche. See ya.